So I'm going to offer proof to you, definitive proof, that we're not on a spinning ball, that the flat earth models that we've been presented with are incorrect, and that the reality that you consider to be real is a simulation. And it's all going to hinge around the equinox. So I'm showing you right here from Google. I did a search for equinox definition, and this is the first thing that pops up right here. It says the time or date twice each year at which the sun crosses the celestial equator when day and night are of equal length, about September 22nd and March 20th. Now if we go here to a definition at dictionary.com, it says the time when the sun crosses the plane of the Earth's equator, making night and day of approximately equal length all over the Earth, occurring about March 21st and September 22nd. So it says all over the Earth. That's not possible. So let's take a look here at the model, the ball model of how this all transpires. And you can see here the September 22nd autumnal equinox. So the sun's at that 23 point, I've heard 4, but here it has 5-degree tilt. And you've got your summer solstice, your winter solstice, spring equinox, and we are coming up on the autumn equinox. Now if you take a look at this ball here, they're saying that it's the same length day all over the Earth. Now what's supposed to be happening is that the equator is lined up directly with the sun. That's what we've all been taught. Now you can clearly see here that the length of the day at the equator right here has got to be much longer on a ball than it is for a place like Anchorage, Alaska up here. I mean, this shadow right here shows that as the Earth spins here, that for like an Anchorage, Alaska, that it would be a much shorter day than for something like a Quito, Ecuador, where it has this full revolution around the equator right here. So we know right away that the definition that we are given of this equal length all over the Earth occurring at the same time is not possible. That is a lie. Now for those of you that have been following my channel, you'll know that I have been paying attention to where the sun sets. My house faces west, pretty much, and I get great sunsets here. Back just before the summer solstice, May 29th, I put out this video, sun north of 30 degrees north latitude. This is an iPhone, and I have the compass app up, and the phone is pointing directly west. And you can see that the sun is north of that. So this is something I've been paying attention to. And then also recently, September 15th, I put out this video about flat earth daylight discrepancies, showing how the days are longer in Austin, Texas than San Juan, Puerto Rico. So this has got me paying attention to what websites like timeanddate.com show as far as the angle that the sun is coming up and how long the day is. So I've been doing a lot of praying, really intense prayers to the Creator, asking for understanding as to what is taking place, what is reality, what is the truth. And this morning, while I was filming an almost full moon just disappear, which I'll put the footage at the end of this video, it came to me what I should check, and it had to do with the equinox. And so with the equinox coming up, that means that the equator should be directly aligned with the sun. And from the other videos, I understood day length and the angle of the sun. And so I decided to start checking cities. And so here is a Google search for cities on the equator. And you can see that this answer right here, which cities are divided by the equator. This city right here in Indonesia appears to be the only city that is actually in both hemispheres. And a close second is Quito, Ecuador. So let's check out this city in Indonesia. So here it is, and this is timeanddate.com. We're going to go down here and with the autumn equinox, what we're looking for is these angles as far as where the sun rises and where the sun sets. And you can see that around here at the 22nd, 23rd, the sun is rising directly east, 90 degrees, and setting directly west, 270 degrees. Now this time of 12 hours and 6 minutes is a little interesting. We can look into that a little bit later. Another important thing for this city on the equator is that at solar noon, right here, the angle. So it's going to be 90 degrees directly overhead right around this time here. So that's 22nd, 23rd. In between here is when it's going to be 90 degrees directly overhead at solar noon. So what I did next was start checking the extremes. So here we're back at Google, and the search is farthest city north in the world. And if you look through here, you'll see that this Longyearbyen, Norway, is considered to be the northernmost town of over 1,000 people. So here's time and date, Longyearbyen, Norway. You can see where that's located over here. And we're going to scroll down here. And you'll see that around here at the 24th, the sun is going to be rising just about 90 degrees east and setting 270 degrees west. This is also around the time that the daylight is equal, 12 hours day, 12 hours night. So it's rising at 90 degrees, setting at 270 degrees. Now let's check our southernmost extreme. So we're back at Google. The search is farthest south city in the world. And we have this Ushuaia pronunciation. I'm probably cremating. But we come here to timeanddate.com again. Here's that city in Argentina. You can see on a map where it's located. Let's come down here and check. And right here around the 20th, we've got sunrise 90 degrees east and sunset 270 degrees west. And once again, this falls at the point where the day length is equal, 12 hours daylight, 12 hours night. So already we can see here that around this time, the equinox, we've got the sun rising 90 degrees east, 270 degrees west, both at the farthernmost city, the equator, and the southernmost city, all at the same time. Now I'm partial to the United States because that's where I live. So let's check out northernmost part and southernmost part of the United States. You can see here that if you exclude Alaska and Hawaii, the answers are these. I'm just going to include Alaska for the northmost part. It's part of the continental North American continent. So we got Barrow, Alaska. Let's check it out. Here's Barrow, Alaska. You can see on the map where it's located. Scroll down here. And you can see that right in here around the 22nd, 23rd, that you're going to have sunrise 90 degrees east and sunset 270 degrees west. Now, this is also right around the time that the length of day is going to be equal, 12 hours daylight, 12 hours nighttime. Let's check out the southmost city in the United States. Here's Google. Here's the search that I did. And from Wikipedia, you can see that the southernmost point buoy is an anchored concrete buoy in Key West, Florida, making one of the extreme points of the United States. Okay. Key West, Florida. Let's scroll down. Here's Key West, you can see. And right here at the 22nd, you can see that the sun is rising 90 degrees at east and setting 270 degrees west. Now this is right around the time where the day is 12 hours daylight, 12 hours nighttime. What I'd like to do now is just look up some key cities in real time live with you right now. Show you that these are not, manipulated or changed charts. They haven't been photoshopped. I'm just pulling them up live from the internet. So here is Google Maps, and we've already done the extreme far north, far south cities. We've done city on the equator. So let's go to South Africa here, and let's check out Cape Town. Going to timeanddate.com, and let's scroll down here, and you'll see around the 20th here, the sun is going to rise 90 degrees east, and it's going to set 270 degrees west, and this is around the time that the day is equal day and night. Let's go back to the map here, pick another city. Let's check out Sydney, Australia. Timeanddate.com. Scroll down here, and the sun's going to rise 90 degrees east, 270 degrees west, right around the same time that the day is equal day and night. Go back to the map here. Where should we go? Let's check out Moscow. There's Moscow. We're going to go to timeanddate.com. Right around here, the sun is going to rise 90 degrees east. It's going to set 270 degrees west, and this is right around the time that it's equal day and night. Let's check out London, England. Timeanddate.com. Right around here, we are going to have the sun rising 90 degrees east, 270 degrees west. This is about the time that we're going to have equal day and night. Where should we check now? Let's do Beijing. Timeanddate.com. Scroll down here. And right around here we have the sun rising 90 degrees east, 207 degrees west at the time that we're going to have equal day and night. Are you starting to get the picture that it does not matter where you are in the world whatsoever? That at the equinox, the sun's going to rise 90 degrees east and set 270 degrees west, and it's going to be equal day and night. That it does not matter if you're in the north, if you're in the south, anywhere you are, the sun is going to rise 90 degrees east, 270 degrees west. That is not possible on a globe. Okay? You cannot be at a northernmost city and have the same length of day as a city on the equator at the equinox. You can't. Look at this. Let's just spin this around on a ball. It's a shorter day up north. Now let's put it on a tilt, okay? Because the equator, we know, runs through Ecuador right here. The day cannot be the same length up here as it is right here. It's impossible. There's just less surface area of a ball Earth when it rotates. It has to be shorter, okay? Same down here. So what I want to reiterate is that by looking at the direction that the sun rises and sun sets on sites like timeanddate.com, and there's many of them like that, it's absolute definitive proof that we're not on a ball. Okay, you cannot have the sun set and sunrise at 270 degrees and 90 degrees for cities in the northern hemisphere and southern hemisphere at the same time. Okay, the ball model is proved wrong 100% by this information. At the same time, the flat earth model that we've been provided so far, if you take a look at this, here's a flat earth model, and you have the equator right here, and you have the tropics right here. This cannot be correct either. You cannot have the sunrise if you're here in Alaska at 270 degrees west, or sunset at 270 degrees west, sunrise at 90 degrees east. At the same time, cities in the southern hemisphere, that is impossible. So how is it that everybody on Earth, come the equinox, will be able to see the sun rise in the east, 90 degrees east, and set in the west, 270 degrees west? It's not possible on a ball. It's not possible on the flat Earth AE map. But it is possible in a simulation. So just take a look here. Movies like The Matrix have given us clues as to how this can be possible. You scroll down here a little bit. I find this interesting. My answer, The Matrix. This is a neurological simulation. We're all gamers, souls inside of bodies. Body equals computer hardware, soul equals operating system software. Our experience, that of a user or simmer. So the explanation for how the sun can rise in the east and set in the west for all of us at the equinox is that they are being rendered for us where we are. For where we are located at the equinox, they are being rendered. We are in a simulation. So what next? Right here, I want to show you my YouTube channel is not monetized, and I'm never going to monetize it. I'm not interested in money. What I want you to do is download my video. I'm going to set the licensing to Creative Commons, which means that I'm not holding any rights, any copyrights to it whatsoever. I want you to download it, I want you to repost it, and I want you to make your own videos. Just like I did back here with the sun north of 30 degrees north latitude. I'm going to play this for you, and I'm going to ask you to look at when the equinox is for your location, and I want you to go out and do this. So real quickly, we're at 30 degrees north, about 410 feet above sea level here. I'm just going to show you where I get this thing lined up. Right with west, so I'm just going to shake it out a few times so we get it most reliable answer we can. It's pointing west. There's the sun. The sun is north of us. In Austin, 30 degrees north. The sun is definitely sitting north. It's 30 degrees. That's it. I just want you to go out, have a compass, use your phone, something, and I want you to record where the sun sets at the equinox, everywhere across the planet. People in the northern hemisphere, people in the southern hemisphere. I want everybody to realize that no matter where you are on the planet, the sun at the equinox is going to be setting at 270 degrees west. Once you realize this, you are going to know that you're not on a ball, that the flat earth model that we've been presented with is incorrect, and that we are participating in a simulation. So while this time-lapse footage that I recorded this morning, September 18th, 2016 plays, I want to just ask you one more time to please, on the equinox, make a video recording where the sun rose, what degree angle, where it's set, the degree angle. Make that video, post it, share the link with me. I'm going to be making future videos regarding this simulation topic and my understanding of it. So hit subscribe as well. But please share this video, please get this out to everyone you can right now. Thank you.